All right, so what do we have to change? Well, let's just follow the pattern here. This might bother you a little bit. Yeah, so the first key pin is pin 2. The second, it's off by 1, but that's typical in programming. So we just add another pin, right? We're just adding a fourth one, right? So we call this fourth pin. And we're going to use port or pin number 5 on the side of the Arduino. So we're just following the same pattern. Really, when you're programming or you're doing anything technical, it's mainly just following patterns. If you can follow a pattern, see or recognize the pattern first, and then follow that pattern, you can do pretty well at the technology, because again, just recognizing where those patterns lie. The buzzer is still going to be buzzer pin 10, so that doesn't change. Now, remember here, we have to tell the Arduino in the setup program. Remember, that only runs once every Arduino program. You have to tell it what kind of port are we using. Is it an input port or an output port? Or in this case, is it an input port that uses the built-in pull-up resistor? And we're going to use just like the other ones. So we're just following the pattern again, pin mode. And we'll say fourth key pin. And then in all caps, input underscore pull up. Be careful of your spelling. If you even spell one thing wrong, the computer gets confused. A lot of, like, I mentioned this a million times, but a lot of people think computers are smart. And in actuality, computers are really stupid. They can only do their math in base 2. And the slightest syntax error, and it gets so confused that it can't even figure out what you want it to do. Right, so now we have this pin. We don't have to change the buzzer. So we've added, a pin variable up here, and then we've added this. We've told the Arduino we're going to use it for output or input. And now we have to add it to this if statement, which is kind of complicated. Well, first of all, if you remember from last time, we're going to change the notes around a little bit. Our scale is here, right? We have C, a low C to a high C. And what I want to do is, in order to match the music, at least relatively, I want the notes to be C, which is the root. Well, no, that's the fifth. A lot of trumpet calls start on the fifth. Do da do da di da do da. That's the fourth. It starts with a fourth actually. So you go from C to F, and then F to A, and then A to C. Okay. So the notes we want are C, F, A, and C. So let's find that. So C, this first one is already set to C, so we're good. We don't have to change that one. But the second one is set to 330, which is E, and we want that to be F. So if you could change 330 to 349, it's weird making your own instrument. Making your own computerized instrument. It's kind of fun. And then there's Caleb. And then we also want the A, so that's 440. So instead of the third one being 392, we're going to say 440. But then we need to get that high octave. Okay. And so what I would do, just so we don't mess things up, well, first we should change these comments. That's an F, and that's a lowercase f. And then instead of a G, we're using an A. But then what I would do is I would copy these 3 lines, because we're gonna add one more, right? We need one more for our fourth button. So I'm going to copy that, and then I'm going to paste it right here. And then I'm going to change the things that need to be changed for the fourth pin. So it's going to say else if digital read, instead of third key pin, we're looking for fourth key pin. Fourth. Remember, we defined that up earlier. So when the fourth key pin drops low, so that'd be the fourth key. So I even update the comments, even though the computer doesn't care about the comments so much. Certainly humans do. And then this will be the high C, and that's capitalized C. What's the frequency of that high C? was 523 hertz. That's 523 cycles per second. So we're going to change it to 523. And now we have all the notes we need to play most bugle calls. Can't say all because I didn't look at all of them, but all the ones I saw, all you need is 4 notes. And then in the case where none of these buttons are being pressed, then you want to shut it off. And so that doesn't change. So all we did was add these three lines of code and make it so it works with the 4th button. All right, so I'm going to plug this in to my Arduino. And we'll give this a try. Now, if you don't have an Arduino and you want to try this out in the I guess it's a Tinkercad's simulator, you can do that too as well. Like I said, though, if you do it in Tinkercad, you don't get a 4. You can get a 3 on the circuit, but not a 4. But it should work the same way, except the speaker on the Tinkercad is awful sounding. It sounds really terrible. So don't get ready to cover your ears when it starts because it's pretty ear splitting. All right, so I'm going to try this now. If you're on the PC, the way you set up the board is you got to make sure you have the right board and you've chosen the right COM port. There's only one here, so that's chosen for me. I've got my board set up. It's all plugged in. I've got my 4 buttons. You can see them. I have them in the right order now. Typically, when you play trumpet, you play with your right hand. But this is more left-handed, I guess. So left-handed trumpet. And now I'm going to upload it. So I'm watching down here. Oh, it asked me to name it. So I'm going to call this 4-button trumpet. And I'll save it. Okay. And it says 4th key was not declared in the scope. 4th key pin. Maybe I spelled 4th wrong, so I better check it. 4th key pin, 4th key pin, 4th key. I forgot the word key. See? So it's obvious to a human that that's the 4th key pin, right? But to the computer, because it's spelled wrong, it can't figure that out. You have to go out and fix it for it, even though it's really obvious to humans. So it's compiling. You can see it's compiling here. And then it tries to upload it. Mine uploads okay. Now it's done. Now it's ready to go. Okay, so I'm going to grab the mic. There's our nodes. I'm trying to get the mic work. Yeah. Okay, so here's some of the bugle calls. I'm going to bring up the music now. We'll see how well they work. Okay, this first one is taps. It's right here. That note right there on the bottom line is the low note. That's the red key. So hard to do the dynamics because we don't have. I guess we do have a volume control. That's the first one, and that's when you'll hear at night when people are time to go to bed. Here's assembly. This is the say you want the commander says, okay, everybody, I need to talk to everybody. We need to assemble on the field. So this is assembly. Loud. One more time. I can't do it. kind of fun. So I get you all assembled, and then finally, Reveille is hard. If you want a challenge, I figure I put a hard one on. Here's a hard one. Oh boy. Yeah, that's kind of a long one, but fun to play. And that's what it sounds like. So, and that's used to wake people up in the morning. That'd wake you up in the morning, I think, get you going. So the goal is today is to see if you can add that fourth button, and then for fun, see if you can play some of these bugle calls. And say if you have a brother or sister that just won't get out of bed in the morning, you could take your little gizmo and try Reveille and see if they get out of bed. I know my sons will sleep until noon if I let them, so I'll get my little battery pack and maybe get them up that way. So anyway, have some fun with this today. Next week, we're going to start focusing on that Simon Says game where we try to remember the patterns. We're adding lights to this circuit. So all the work that we're doing on this circuit, we're not taking it apart and put it back together each time. We're just adding a little bit more every time. Today's task is just adding that fourth button so we can play the bugle calls, and then starting on Monday, we'll start building our first electronic game and see how well we do playing our own game. I'm going to be trying to build a VR computer or repair one next week. So I'll bring in the pieces here, maybe show it off in class so you can see kind of what it takes to build a computer from scratch. That'd be kind of interesting. That's super duper electronics if you're into that. But have some fun with this today. Maybe show your folks once you get it working. If you do, it's kind of a cool circuit. And if you can play the music, you get extra credit, bonus points for me because you can actually play the parts. Hopefully, I was trying to find a way to rewrite this. I just didn't have enough time to rewrite it in colors and make it understandable for people perhaps who don't read music so well.